We're going to start with reaction 1, and in reaction 1 I'm starting with a beaker of water. And before I begin, I'm going to test this water with litmus paper. And we're going to do the proper chemical procedures of dipping the stirring rod in and tapping that to the test papers. And you can see the blue paper stayed blue and the red paper stayed red. And so that combination of no change lets me know I have neutral water in there, which is a very good thing considering it came out of the faucet. Now I'm going to actually do reaction 1. So I have water in the beaker, and I'm going to take a small piece of sodium metal, and I'm going to place the small piece of sodium metal into the water in the beaker. So you can see that it certainly gives off a lot of energy. The sodium is spinning around the beaker. It is producing a gas, and that's what's actually thrusting it around the beaker, and you can kind of see the fumes coming off of it. Sometimes it's energetic enough that that gas will actually even catch on fire. So sometimes it spins around as a little tiny fireball. Pretty cool looking. Certainly the larger the piece, the more likely it'll catch on fire, but you don't want to go too large as it certainly has the potential to explode. Not that exploding sodium makes all that great an explosion. TNT is obviously better, or they would use sodium instead. But this is a safe quantity to work with in lab, and it illustrates what we need to illustrate. So now that the reaction is obviously finished, we're going to retest the litmus paper. So I have 2 new strips of litmus paper, and I'm going to again take my stirring rod and dip and tap onto my paper, and dip and tap onto my paper. And now we see that the blue paper stayed blue and the red paper is turning blue. So this combination of blue on both is indicating that we have a base. So along with forming a gas that moved the sodium around the beaker, it formed a base. So as you go through and you predict and balance that reaction, be sure your products are, one of them's a gas and one of them's got to be a base. It's a way to show on paper that what happened in real life has the real consequences that we show on paper.